Hi guys, in this video we're gonna see how we're gonna build a circuit using an IC. Now let's build this circuit. We're gonna need 3 ICs with the exact numbers and also a switch. Here we go. I place the ICs in the switch on the breadboard. Keep in mind that we just care about the last 2 numbers of the IC. The rest is different by the manufacturer. Keep in mind also that the little notch is on the left always. What do we mean by this is the LS is not that such important thing. It's just different from one manufacturer to another one. In the middle here, I don't use the LS. What we care about is the 08, 32, 04, the last 2 numbers. Next, we're gonna need to know where we put the power and where we put the ground. So here we need to put the power on pin number 14 and we put the ground on pin number 7. How we would know that? We know that from the datasheet. Let's see how. According to the datasheet in front of us, that tells us is the first IC number A, which is the 04, tell us that the VCC should go to the pin number 14 and ground could go to pin number 7. Same thing for 08 and same thing for 32. Now, according to the circuit, we have 2 inputs, so we need 2 pins from the switch. That means 2 resistors, and we need to power these 2 pins. First thing, I'm gonna grab the resistor and put it between the pin 1 of the switch and the ground. Same thing with the resistor 2, but this time with pin number 2. And then I need to power those 2 pins from the from the 5 volt. So I'm bringing wire and let's power up pin number 1 and pin number 2. Hence those pins we're gonna use as an X and Y or A and B, whatever name you wanna give them. The colors of the wires are no difference. You keep asking me if the color will make a difference. No, it doesn't. But it's good if you wanna just match the colors inside your circuit or make it look clean or awesome, something like this. Now, after we power the switch will be the control for the power if we want to transfer it from the upper part to the bottom part into the resistors. So here we have the 5 volt coming from the source and then to the upper section because we know that the column is connected. But if the switch was on, then the power will be on X and Y. If the switch is off, then X and Y both will be off, and the resistors to take care of the noise, if there is any millivolts. Now keep in mind that we are using pin number 1 and pin number 2 from the switch as an inputs. Now, with that being said, let's complete the VCC and the ground. I double check that I do have the 04, the correct IC, the little notch on the left side. So pin number 14 is the VCC and pin number 7 is the ground. Let me connect that. Keep in mind that it is really important to look at the notch and make it to the left because if the notch was on the right, the map will be changed and we will not be powering it correctly. Keep in mind also that the column is connected, so the entire 20 aisle or column right now is represent the VCC, and the entire 16 column is represent the ground right now, which is pin number 7. So on the VCC there should be only 1 wire on each IC. On the ground there should be only 1 wire. Now I connected all the VCCs and the grounds for each IC. Now the circuit that we want to build is complete. Now let's say we want to build this equation into a circuit. Now we know A and B are the inputs and we need OR gate, C is the output. Now we know that we need an OR gate. We see that IC 32 have an OR gate, so we're gonna use that one. Now, hence we powered pin number 1 and pin number 2 from the switch, we're gonna use pin number 1 and pin number 2 as an AB, as an XY. Here, I'm gonna place the first input, which is A or B. So let's say it's A. Now, using the datasheet again, I'm gonna decide, for example, I'm gonna use the second OR gate. So pin number 4 is an input, 5 as an input, 6 as an output, and remember the little notch. Now, I know that I'm gonna use pin number 4, so I came here, 1, 2, 3, 4. Then I insert my A input into it. In that way, I have A on pin number 4. Now, lots of you guys gonna say, hey, I don't have a long wire that is gonna reach, and it's pretty common problem. What I'm gonna do is I'm gonna put the wire into a pin or into an aisle that I'm gonna use. So as you can see here, I use this column, which is not connected to anything, and hence the column is connected to each other. Every pins, I'm gonna use the pin next to it, and then I'm gonna bring it also to 1, 2, 3, 4, and then I'm gonna hook it up into this pin, and this is I having A. Keep in mind, like you are right now transferring A from the switching point into this one, so we still need B. So I'm gonna transfer B into pin number 5. Now, if you use pin number 4, then you have to use the other input. So it is pin number 5. And you had to stay with an output on pin number 6. So you cannot use, for example, pin number 8 to get the output. You have to stick to the same circuit that you are using, to its inputs and to its outputs. Okay, and remember, this circuit is already been used. So if you need another OR circuit, you cannot use this one. This one is already been taken. You have to use another OR circuit if you want another circuit. Now the white wire here represent the output, which is pin number 6. Now let's remove all the wires. Keep in mind, guys, that these wires are the mandatory wires that let the ICs working. So these are very important, and keep in mind that the red wire still need to power up from the power supply as a positive 5 volt, and then the black one needs to be powered on the negative of the same input of 5 volt. I would recommend use output 3. If you use another output, please adjust the voltage to make it 5 volt. Okay, well, let's say we want to build another circuit, which is not X or not Y equal to A. We're gonna know that we have two inputs, X and Y. We're gonna take them through a switch, so in order to control them. Then after the switch, we're gonna take both of them into 2 NOT gates, and then the output of the NOT gates is gonna be an input for an OR gate, as we're gonna see, and then the output of that OR gate is gonna be A. So let's see how we could do it on the breadboard. So now we're gonna take the first input, which is X, into the first pin. Why we took it to that pin? We came to the datasheet, identify what is the NOT gate. We know that there's the 0, 4, and this is the 0, 4. So the first one is a NOT gate, and we could use the first input, the third input, the fifth input, 9 input, or 11 or 13, whatever we want. Here, I'm gonna choose the first input. So the second pin number 2, is gonna be the output. Okay, so pin number 2 is gonna be the output, or it's gonna be NOT X that I'm gonna use as an input to the OR gate. Same thing for the OR gate. Here I'm gonna use the first one on the top. So pin 13, pin 12 gonna be inputs. So I'm taking the output, put it into pin number 13. Next, I'm gonna grab another input, which is input Y. Now I cannot use the first inverter because it's already gone. So I'm going to use the last one in the row, which is pin 5. So pin 6 going to be an output. And then that output going to be an input for what? For pin number 12. Now I had to stay on the same circuit that I chose before. Hence I use previously pin 13. Now I have to mandatory use pin 12 as an input. Okay, and then so I cannot use pin number 10, for example, and then pin 11 would be the output. Okay, so I have to take 13, 12 as an input, 11 as an output. So here we go. I'm taking the other pin connected to pin number 12, and now pin number 11, it's gonna be what? It's gonna be my output, which represent A, and in that way we complete the circuit. So here we go, the white wire is output A. Thank you so much for watching, guys. I hope that you enjoyed the video.